Hello friends, very good morning. Myself Dr. M.H. Annaya, and in this video we are going to work out a problem on the section of a square prism. Friends, as the name indicates, a square prism will have a square base and a square top bounded by four rectangles, each having height h and side say a. And let's see what the question we have for today's video. The question reads like this. A square prism having shorter edge 30 mm resting on one of its square face as an HP. So the prism is having side of the shorter edge as 30 mm. It will have a square base 30 by 30 at the bottom, 30 by 30 at the top. And this is being placed on HP with all the lateral surfaces equally inclined to VP. Friends, here all the four rectangular surfaces are equally inclined to VP. Or the same problem can be stated as all the four shorter edges are equally inclined to VP. Or two of the adjacent shorter edges equally inclined to VP. So these are the three different ways how this problem can be stated. So it's resting on HP with all the lateral surfaces equally inclined to VP. And it says it is cut by a section plane, a vertical section plane. So a vertical section plane is just like a very sharp vertical blade which is parallel to VP or which is parallel to the board in this case. And it says the true shape becomes a rectangle of size 20 mm into 60 mm. So friends, whenever any of the prisms or cylinders while placed on HP on one of its end faces, and if it is cut by a vertical section plane, whether it is parallel to VP or inclined to VP, you are always going to get the true shape as a rectangle. This concept you should remember. And in this particular problem, they have given the side of the base and they have not specified what the height of the solid is. So let us find out that, let us think over and solve this problem. Friends, here, let me mark the XY line indicating the line of intersection of VP and HP. And on this we will mark VP by HP, indicating first angle projection. Now friends, the prism is placed with two of the base edges equally inclined to VP. All the four edges are equally inclined to VP. In that case, we know the side of that. So I am going to write a square here of the given side, that is equal to 30 mm. And here I will project all these corners to the front view to obtain the front view of the solid. Friends, front view appears as a rectangle. And here we are not given with the height of the prism. A very interesting problem, you see. Now how to take that? So whenever this is being cut by a vertical section plane, you are getting a rectangle 20 mm by 60 mm. So 20 mm is the side, and whatever the height they have given you, that is going to be the height. So if it is 80 mm, you get 20 by 80. If it is 100 mm, it is going to be 20 by 100 and so on. So I have not specified what the height is. You will have to think over and then take the height as 60 mm, because only if you have 60 mm height, you can have a rectangle 20 by 60. This is a concept, very important concept. Friends, it is a prism. I will mark the center of this as O, comma O1, and I will mark this as AA1, BB1, CC1, DD1, because it is a prism For prisms and cylinders, you'll have to have double marking. So friends, I will produce all these, project them to the front view and obtain this front view, which is going to be a rectangle of this height, and this height is derived from this true section, and we will join this also. Friends, we have the front view, we have this top view, this is O dash, this is O1 dash, the axis is perpendicular to HP, as you all know. This is A dash, B dash, C dash, D dash. Bottom, total number 1, A1 dash, this is B1 dash, this is C1 dash. Now friends, the object is placed on HP, and you observe here, these two are all the four rectangular faces are equally inclined to HP, and this will be obviously equal to 45 degree. 45 degree, and on both the sides you are going to have 45 degrees. Now friends, what is left over? It is being cut by a vertical section plane, and that will have a width of 20 millimeter. So what is to be done now friends? I have to have 20 millimeter width here. So I am going to extend this line downward and mark 10 millimeter on either side. Say this is 10 millimeter here, 10 millimeter on the other end. I am going to produce these two to cut these sides here, and friends, this is the width which is equal to 20. So the object is being cut like this, and I'll just mark this as section plane. Yes, yes. So after this is being cut, the portion that is left over is the portion I am showing now. This is the part of the prism that is left over after this is being cut. This bottom portion is removed. Friends, this has got a dimension of 10 millimeter. This also has a dimension of 10 millimeter, because the total width should become 40 millimeter, sorry, 20 millimeter. Now I extend this line, friends, both to the top and bottom faces of the solid, and let's mark the true shape of this section. So friends, I am going to extend like this, a vertical line from the points, again another vertical line here parallel to that, it will be at the equal distance, and friends, this is that part of the solid which is seen as true shape. So I am going to darken this part of the solid that is true shape, which is a rectangle of 20 by 80. So this portion of the solid is going to be hatched or sectioned here. And friends, you are getting this front view with this section. So I can call this sectional front view, that is SFV. We can darken the remaining part of the solid by completing the front view of the solid like this. Friends, here you can see that the true shape is this rectangle. I will say 1, 2, 3 and 4 is the rectangle, and this has got a dimension 20 millimeter by this is going to be 80 millimeter. Sorry, this is 60 millimeter. That's equal to the height of the solid. It's a very interesting problem on the section of solids. Friends, so you got the sectional front view, you have got this top view, and only you have to darken only this portion. I will call this section plane SS, and say this is the top view TV. And what else is being asked, friends? You are able to find out what is the position of the section plane with respect to axis. Friends, the axis is here, the section plane is here, SS is here, and we have been asked to find out how far is that section plane from the axis. So we'll have to just measure this distance, and this will give you distance of section plane, distance of SP from axis OO. A nice problem you can see here. This distance you can measure using a scale. The height of the prism, is 60 millimeter. Write down the answer here. It is 60 mm. Because only if you have this height of 60 millimeter, you'll be able to construct this rectangle. And friends, true shape. So I have told you at the beginning of the session that whenever a prism or a cylinder is cut by a section plane parallel to the vertical plane, the true shape is going to be a rectangle. So here this is the true shape and this true shape is a rectangle. I will say this is true shape of section which is a rectangle 20 millimeter by 60 millimeter. Friends, I hope the presentation was interesting. Please go through the complete video without skipping any part of it. And if you like this video, do share this video with all your friends without fail. I thank you very much for watching my YouTube video. Have a blessed day. This is Dr. M.H. Annaya signing off.